So in this video, I will demonstrate how to compute the variance and standard deviation using the traditional method. So step one is we take the data set and compute the sample mean for the data set. So this is found by adding up all the values and dividing by 7. 7 is the number of values. That's going to give us 63 divided by 7, which is 9. Next, we compute the square difference between each data value and the mean. To simplify this process, I've created a table. The first column, I list the individual data values from the data set. The second column, I subtract each data value and the mean. So recall the mean is 9, so we take 10. 10 minus 9 is 1. 7 minus 9 is negative 2. 8 minus 9 is negative 1. 2 minus 9 is negative 7. 15 minus 9 is 6. 12 minus 9 is 3. 9 minus 9 is 0. Next, we square all these differences. So 1 squared is 1. Negative 2 squared is 4. Negative 1 squared is 1. Negative 7 squared is 49. 6 squared 36. 3 squared is 9. 0 squared is 0. Once we have these square differences prepared, we will use them to compute the variance. So in calculating the variance, to avoid overestimating the mean, we divide the sum. So we divide the sum of the square differences by, we would think it's n, but it's actually n minus 1, where n is the total number of data values, so that's going to be 7. So 7 minus 1 is what we divide by. This is called an unbiased estimate and corrects the overestimation. Also, I just want to mention that this symbol, it's called sigma. It's used to represent the sum of a set of numbers. So when you see this symbol, think of you're adding up an entire sum of numbers. So the traditional formula for the variance is s squared equal to the sum of all of these differences in the last column divided by n minus 1. So if we take all of these differences we computed and add them together, 1 plus 4 plus 1, etc., and then divide by 7 minus 1, we end up with 100 over 6, which is 16.67, and that's the variance. We now use the variance to compute the standard deviation. We take the square root of the variance, 16.67, to get 4.08, and that is the standard deviation. Thanks for watching the video.